All right, what's up, everyone? Here we are in section 4.6, and now we're going to look at several very important properties of logarithms that are going to be able to help us in solving some logarithmic equations in the coming sections, okay? So let's start with some basic log properties. Now, these work for all logarithms, no matter what their base. Log base a of 1 will always equal 0. The reason for that is any number raised to the 0 power is automatically 1. Okay. And then log base a of a will always equal 1. That's because a raised to the first power is itself, right? So what we're seeing in that property is that whenever the base of the logarithm and the argument are equivalent, we are always going to equal 1. All right. Now for the next set of properties, I'm going to use the letters M, N, and A to represent positive real numbers where A cannot equal 1, and then R is going to be able to represent any real number, okay? So first property here, we have A being raised to the power log base A of M. So notice that the base and then the base of the logarithm are the same value. So anytime that's true, this is just going to equal the argument of that logarithm, okay? So kind of give you an example of that. If I was working with 2 raised to the power log base 2 of 5, I know that that's just going to equal 5, okay? Log base a of a raised to the power of r, this is just going to equal the power of r. And this is nothing more than an extension of this property right here. Here, log base a of a, that's being raised to the first power, right? And notice it equals 1. Well, this property is just stating if the power is anything other than 1, that's what the logarithm is going to equal, okay? Now, the next 3 properties are the main properties of logarithms that we really want to focus in on. The product, quotient, and power properties. And these 3 properties are based on the fact that logarithms represent exponents. So the properties of exponents are going to be at play within these 3, okay? So your product property says that if you have log base a of the product m and n, so if your argument is able to be thought of as a product of 2 numbers or expressions, then this can be broken up into log base a of m added with log base a of n, okay? Think about properties of exponents. If I'm taking 2 exponential expressions and I'm multiplying them together, as long as they have the same base, then I'm able to add their exponents, right? And that's exactly what we have going on here. Log base a of m represents an exponent. Log base a of n does as well. Those 2 exponents are being added together, okay? It's very similar for the quotient property. Log base a of m divided by n. This can be broken up into log base a of m subtracted by log base a of n. That's because you subtract exponents whenever you're dividing 2 exponential expressions, okay? And then power property, log base a of m to the power of r. This can be thought of as r times log base a of m. So r is a power, and then log base a of m is a power. You are multiplying 2 powers together. This is nothing more than our power to a power property of exponents, okay? All right, so we want to practice being able to utilize these properties, and we do so by expanding and condensing expressions that involve logarithms, okay? So in our first series of problems here, we're asked to expand using properties of logarithms, okay? And this shouldn't have a base on it, so let's rewrite this. This should actually say the natural log of x squared y. There should be a 3 there, okay? So if we want to expand that, there's two properties that can be used here. I'm first going off the fact that x squared is multiplying y within this argument. So that means this can be broken up with the product property. I can think of this as the natural log of x squared added with the natural log of y. Okay. And then the only other property that can be used here is that power property with the fact that x is being squared here. I can now write this as 2 times the natural log of x plus the natural log of y. And this would be as expanded as we get here. Okay? All right, next logarithm. So this is a common logarithm of the square root of a divided by b. So I can treat this, I'll use a quotient property to start, and I'll make this common log of the square root of a subtracted by the common log of b. All right. And then from here, I have to recognize that when you square root a, isn't that the same as raising a to the half power, right? So I can actually use another power property here, and I can bring that 1/2 down in front and multiply it by the common log of a. So you can leave it like that, or you're commonly going to see it instead of 1/2 times common log of a, it will often be written as common log of a divided by 2. Okay, and now that expression is as expanded as it can be. All right, now let's go in the other direction. Right here we have multiple logarithms either being added or subtracted with one another, and we want to try to condense them down into a single logarithm. Okay, so notice that over on the left here, these two logarithms are being added together. So I could use a product property, and I can multiply their arguments together. So this is going to become log base m of the product between x and x plus 2. And then I would actually multiply that out. This would be log base m of x squared plus 2x. And make sure you have the x squared plus 2x in parentheses to show that that entire expression is the argument of the logarithm. Okay. Now, maybe I skipped over this fact, but understand you could only use that product property because of the fact that both of these logarithms have the same base of m. Okay. All right. In the second example here, I'm going to use two properties, and starting with the fact that log base 2 of x is being divided by 3, isn't that the same as 1/3 times log base 2 of x? So when I think of it like that, I can use a power property. I can bring that power of 1/3 up on x, and we have to recall that raising something to the 1/3 power is the same as cube rooting it. Okay. And then from here, I'm noticing that these two logarithms are separated by subtraction. So that's going to allow me to use a quotient property. And I can now write this as a single logarithm, log base 2 of the cube root of x divided by 5. And let's put that in parentheses. Okay. All right, so hopefully, each of those examples, made a lot of sense to you because those were meant to be the easy ones. Now we're going to move into some more sophisticated, more difficult ones. All right, so notice the directions here. Expand into a sum and difference of logarithms expressing powers as factors. Okay, when we say expressing powers as factors, that essentially means to use this power property, right? If I'm bringing the power of r down in front and it's multiplying log base a of m, r can now be thought of as a factor, okay? All right, so there's a lot going on here. Log base a of the cube root of x squared plus 2 that's being divided by x to the fourth multiplied by x plus 2 cubed. All right, so I'm actually going to handle the fact that this argument has a fraction within it first, okay? That allows me to use a quotient property, and I'm going to break this up as log base a of the cube root of x squared plus 2 subtracted by log base a of that entire denominator, x to the fourth times x plus 2 cubed. All right. And then from there, I'm going to focus in on the fact that the second logarithm is still a product of two expressions. X to the fourth is being multiplied by x plus 2 to the third power. So there I can use a product property. And I'm going to break this up into log base a of x to the fourth plus log base a of x plus 2 cubed. All right. And notice how I still have those last two logarithms. I have them in brackets. That's really important because it shows that this subtraction right here, it still applies to both of these logarithms. It has to be distributed, okay? Now really the only thing left to do is to use the power property, and I can actually use it 3 times here, okay? So in the first logarithm that has the cube root within it, we know that that's the same as being raised to the 1/3 power. So I'm going to bring that in front, and it's going to multiply the logarithm. But I'll actually write it, instead of multiplying by 1/3, I'll write it as division by 3, like this. Right, and then log base a of x to the fourth, I can bring that power of 4 in front, so I'll make this minus 4 times log base a of x, and then minus, because that negative has been distributed, 3 times log base a of x plus 2. Notice I'm leaving x plus 2 in parentheses. All right, and this would be as expanded as you can make the original logarithmic expression. Okay. All right, now let's go in the other direction. Here we're asked to condense into a single logarithm. All right. So here I'm kind of going in reverse. So notice on the previous example, the last step was using the power properties. Well, when I'm going in the other direction, I'm actually going to make my power properties my first step, okay? So I'm noticing that I have this 21 that's out in front of the first logarithm and multiplying it. So that can be brought up as a power on the cube root of x. So I'm going to think of this as log base 3 of the cube root of x being raised to the 21st power. And that's the only power property that can be used here. All right. Now, the cube root of x, if I raise that to the 21st power, that's just going to equal x to the 7th. All right. Okay, so now I'm going to focus on my power or my product and quotient properties, and I'm going to do this moving from left to right, just like I would with normal order of operations. So I'm going to combine these two logarithms together. They're being added so I can use a product property, and I can multiply the arguments of x to the 7th and 9x squared together. So that's going to give me log base 3 of 9x to the 9th. Okay. And then I have two logarithms left over. There's subtraction between them, so now I can use a quotient property. I can think of this as log base 3 of 9x to the 9th over 9. And nothing against us being able to reduce these 9's away. And now I have log base 3 of x to the 9th. And that is as condensed as we can make this. Okay, so that'll be it for this video.